For our electric dipole field, when the distance r was much greater than the distance we had 2a between these two charges, and we introduce an angle theta, and because of that, we have our r hat and our theta hat directions. We've been expressing everything in terms of I hat and j hat, and so we have to be a little bit careful about some vector analysis here. This is the angle theta, and we have also that, therefore, this is the angle theta. And what we see is that if we expressed r hat, so if we call that I hat and called that j hat, then r hat has an adjacent component in the y direction, an opposite component in the x direction, so that's sine theta I hat plus cosine theta j hat. And our theta hat is, again, it has a negative component in the y direction and a positive component in the x direction. The x component is adjacent to the angle, and so we have our vector decomposition. And now we wrote down our electric field in terms of r and theta, and we had k times the dipole moment over r cubed. Again, in this problem, the dipole moment was 2qa. And in here, we had a factor 3 cosine theta sine theta. And over here, we had a factor 3 cosine squared theta minus 1. This was our I hat component. And this factor was our j hat component. Now, what I'd like to do is express everything in terms of r hat and theta hat. And the reason we want to do that is it's often a very convenient way to express the dipole field. And what we're going to do is play a few mathematical tricks here. First thing we'll do is write this r and theta, kp r cubed. And what I'm going to do is I'm going to write this as two terms. I'll have a 2 cosine theta sine theta I hat plus another term cosine theta sine theta I hat. And I'll have a second term, which I'm going to write as cosine squared theta minus 1 j hat. But I'm still missing a factor 2 in here. So I have a 2 cosine squared theta j hat. OK, that looks a little bit complicated at first. And now I'm going to use the trig identity that cosine squared theta minus 1 is minus sine squared theta. And I can rewrite my expression for our field as kp over r cubed. And now I'm going to collect these factors. I'm going to pull out a cosine theta here, there, and a 2. So I have 2 cosine theta. I have sine theta I hat plus cosine theta j hat. Let's just click the terms off that we've used so far. And the second term is I'm going to pull out a sine theta. And I have cosine theta I hat. But remember, this is minus sine squared theta. I'm already pulling out a sine theta. So I have a minus sine theta j hat. And now let's express this in the following way. We have kp over r cubed. Our first term is 2 cosine theta, and that is precisely r hat. And our second term is plus sine theta. And here we have cosine theta minus sine theta, and that is theta hat. And finally, that is the expression for our electric dipole field in polar coordinates. Now remember, what precisely is this? This was the leading order contribution to the electric field when R is much bigger than A. And now we have a nice, concise expression entirely in polar coordinates.